Hello, welcome to our last lesson on chemical equations. We will be looking at ionic equations in this lesson. I am your teacher, Mr. Nkumbi Alex. Let me introduce ionic equations. By the name itself, ionic, it means that we are dealing with ions in this case. So we are dealing with ions. Okay, so I was saying that by the name itself, ionic equations, it means that we are dealing with the ions. So we are looking at chemical equations where ions are involved. But you need to know that in a chemical reaction where ions are involved, not all the ions are taking part in a chemical reaction. So what we want to do is to remove those ions which are not taking part in a chemical reaction, so that we can only remain with those ions that are involved in a chemical reaction. So you need to understand also that for you to be able to write an ionic equation, you need to first of all learn how to write a balanced chemical equation. So it is good that we have already dealt with the balancing chemical equations. So I'll pick two of the equations we did from there and see how we can use them to write ionic equations. So the first equation I'm going to use is for the reaction between zinc metal and hydrochloric acid, which we already looked at. Hydrochloric acid, and the products were zinc chloride, and the other product was hydrogen gas. Okay, so I want you to pay attention so that you understand how we can use this. We can construct an ionic equation from a balanced chemical equation. So let me also show how this equation balanced. There was a 2 here in order to have it balanced because of these 2 on chlorine and the 2 on hydrogen, so we put a 2 here. And also the state symbols, this is solid, then this is aqueous. So we are progressing in the stages actually. You cannot write an ionic equation if you cannot put correct state symbols, then it will be very difficult for you. Okay, so this is actually how the equation was. Now for us to be able to write an ionic equation, the first thing that we need to do, the first rule, is that wherever you see the state symbol aqueous, split that compound into its ions. So you can see here we have aqueous and we have aqueous here. Don't touch where you see solid and where you see G and where you see L. So the only state symbol that we should check for when we start splitting is AQ. It means that that substance is actually made up of ions, so we can split it. So we are going to that stage. So zinc is left just like this, solid. Now here we have aqueous, so we are going to split this into 2 hydrogen. Take note that the 2 here is for both hydrogen and chlorine. Now hydrogen will have a positive charge here, because hydrogen, when reacted with non-metals, behaves as a metal. Now the positive sign that I have put here is according to the valence of hydrogen. Hydrogen has a valence of 1, so I put positive 1. If it had a valence of 2, I was going to say 2 positive, but it has 1, so that's why I just put a positive sign there. Plus chlorine here will also have a 2 in front, because this 2 was shared between hydrogen and chlorine, so there will be a 2 there, then there will be chlorine. Now chlorine is a non-metal with a valence of 1, negative, because chlorine is a non-metal, so it will gain an electron. That is the meaning. So we put back the state symbols which were there. The state symbol which was on this compound was aqueous, so we put it on both, because these are the products after splitting this compound here. Then you say now the products, zinc chloride is aqueous, so we are going to split it, so it gives us zinc. Now you can see zinc here is no number in front, so we just say zinc. Now zinc has a valence of 2, in fact it is the 2 that came here, so we are going to say 2 positive, because it's a metal, it's supposed to be positive. If it was sodium, you can say sodium positive. I will show you one reaction where we'll be looking at that. Okay, for now let's concentrate on the one that we have at hand. Then this one, the other thing is, because we are splitting this, is chlorine. Now chlorine here, there's a small 2 here. Now when we are writing ions, we don't put a small 2 there, because it will mean chlorine molecule. So we are going to put that 2, which is small, in front of chlorine, and then there will be a 2, there will be a negative, since chlorine has a valence of 1, so it is 1 negative, because chlorine is a non-metal. And then the last thing is hydrogen, which is a gas, so we just indicate it as a hydrogen gas there. Remember to put the state symbol here is aqueous, and here it is also aqueous. Why? Because the parent compound we have split is this one, it was aqueous. When you reach this stage, you now check on both sides of the chemical equation, look for things that are exactly the same and remove them. So for example, we can see that we have 2 CO negative here and we have 2 CO negative here, so this will be removed, so cancel it out. Even this one we cancel it out. But zinc is solid here, we can't see zinc exactly the same as this. This is zinc ion, this is zinc metal, so they are not the same, so you leave them. Hydrogen, this is the 2 ions, 2 aqueous. It's not like the way this hydrogen is. This is a gas. Oh, by the way, there was a 2 here, so it's 2 there. Yeah. So the only things which were appearing on both sides exactly the same, it is this chlorine ion here, the 2 chloride ions here, and the 2 chloride ions here, so we have removed them. They are called the spectator ions. It simply means they were not actually taking part in a chemical reaction. Just like when you go to watch a football match at Levy Stadium, you are a spectator, you are not participating. So that is exactly what is happening in this chemical reaction. So we can now rewrite this equation as zinc metal, so zinc solid reacting with these 2 hydrogen ions here, so 2 hydrogen ions positive, and we put the state symbol aqueous, and the product, so this one will not write it, we forget about it, it was removed. So the next is zinc 2 ions. Okay, so you can see there is a difference between the zinc we have on the left side and the zinc on the right. Again, this one is not going to be included because it was removed. So the next thing is the hydrogen gas. So what we have written here is an ionic equation for the reaction between zinc metal and hydrochloric acid to produce zinc chloride and the hydrogen gas. So this is what we call an ionic equation. You can play this video as many times as you can so that you understand what we are dealing with here. Otherwise, allow me to proceed to the next example. So in our next example, let us look at the reaction between the other example we had. The other equation was the magnesium metal reacting with the sulfuric acid, which is H2SO4, and the products were magnesium sulfate, and apart from magnesium sulfate there was also hydrogen gas produced. And I told you that this equation was balanced the way it is. So the state symbols are magnesium is a solid, sulfuric acid is aqueous. I told you already that all acids are soluble in water, so aqueous. Magnesium sulfate is aqueous also because it is not a sulfate of lead or barium, which are insoluble. Hydrogen is a gas. So the next step now is to start splitting. So we only split where we see the state symbol aqueous. So here we just rewrite it the way it is as magnesium sulfate, magnesium solid, which is a metal. Now here the next part is to be split because this is aqueous. So hydrogen, we shift the two like I was explaining in the previous example about chlorine. We will not write it as H2, because if we write as H2, it will not be an ion, it will be a molecule. So we take these two and put it in front, so it is 2H, and then we indicate a positive. Hydrogen should always have a positive charge when you are writing its ion. Plus the sulfate here is a radical, which we already talked about. Remember radicals. So the sulfate radical is SO4, and it has a valence of 2, and it will be negative. Okay, so you indicate the state symbols for these two. This is aqueous, this is also aqueous. Then on the product side, we are going to have this. So now this compound is aqueous, so magnesium will be shown as Mg. Now magnesium is a metal with a valence of 2, so it will be 2 positive. For metals, positive, and for hydrogen. Then we have the sulfate radical here, which is SO4, and it will be 2 negative because it has a valence of 2. And we are going to have this hydrogen gas, which will just relate the way it is as hydrogen gas. The next step now is to cancel out ions appearing exactly the same on both sides. So we can see that the sulfate radical here and here are exactly the same. By the way, the state symbol here is aqueous, and here it is aqueous. So I have removed the sulfate from both sides because it is appearing exactly the same. Magnesium here is solid, magnesium here is aqueous, it's an ion, so we can't say they are the same. So we write it as Mg solid reacting with 2 hydrogen ions here. It's about to start raining. Okay, aqueous there. Then this is the one that I've shown you. Then we'll avoid this one because it was removed. So the next part is this magnesium. Now this magnesium is different from the magnesium we have here because this is an ion, so it will be 2 positive. Okay, and it will have a state symbol aqueous, and we avoid this because it was removed. So the next part is hydrogen gas, so H2, which is a gas. These reactions are very important in future when we'll be looking at oxidation and reduction. I will use these examples to show you the change. Here you can see magnesium is solid, here it becomes an ion. Here hydrogen, which was an ion, becomes a gas. So we shall talk about oxidation and reduction later, but for now we are just interested in showing ionic equation. So this is an ionic equation we have constructed from the reaction between magnesium and sulfuric acid to produce magnesium sulfate and hydrogen gas. So you can be given a chemical equation like this one, and then they say use this chemical equation to write an ionic equation. Or sometimes they will just tell you magnesium reacts with sulfuric acid to produce magnesium sulfate and hydrogen gas. Write an ionic equation. So for you to write an ionic equation, first of all you write an equation like this one, a chemical equation. You balance it and you install state symbols. Then you split the ions where it is aqueous. Then you cancel out ions which are exactly the same on both sides of the equation, and what will remain with now is an ionic equation. Okay, the last example we are going to have is for the reaction between sodium hydroxide and hydrochloric acid. Okay, so the last example I want us to look at is for, I'll begin with a word equation. So sodium hydroxide. So sodium hydroxide reacts with the hydrochloric acid, and we shall look at the products together. Actually, at school I told you how to predict the products of a chemical reaction. So sodium hydroxide is written as NaOH. Now I know that you know how to write this by now. So this is sodium hydroxide. It is reacting with the hydrochloric acid, which is HCl. In my previous lesson I gave you the formula for common acids. So this is hydrochloric acid, and when the reaction takes place, sodium will react with the chlorine here and will produce sodium chloride, which is a salt. When we look at acids, bases and salts, you understand this, the second topic of grade 11. Then this hydrogen and OH will react and they will produce H2O, which is water. Okay, so the next thing is we want to balance this equation. Check, we don't just start doing things, we have to check first of all. So sodium 1, oxygen 1, oxygen 1 here, hydrogen 1 plus 1, 2. So we're looking at this side, the left side of this equation. So there are 2 hydrogen atoms, this one and this one, and we have 2 hydrogen atoms here. Chlorine is 1 here and chlorine is 1. So basically this equation is balanced as it is. Let's just now put state symbols. So for hydroxides, according to the rules of solubility I gave you, it is aqueous because it is hydroxide of sodium. Hydrochloric acid being an acid, it is aqueous. Sodium chloride is aqueous. Follow the rules of solubility, please. Don't get surprised how I'm putting this aqueous. And water is a liquid. Follow the rules of solubility in the previous lesson on solubilities. So we have installed the solubility, the state symbols. Now we go to splitting. So I told you we split wherever we see aqueous. So here we are going to split. It becomes sodium positive. Now sodium is a metal with a valence of 1, so it's just positive. If it was a metal like magnesium or calcium, which has a valence of 2, we are going to say 2 positive. We don't say positive 2, please. Don't say positive 2. This is wrong. You say 2 positive. Okay? So sodium positive and OH here negative. Hydroxide has a valence of 1. So we just show a negative. If it had the valence of 2, we would have said 2 negative, like in the case of carbonate and sulfate. So these are coming from substance which was aqueous, so we indicate their state symbols as aqueous. Then this is reacting with hydrochloric acid. Also we split it because it is aqueous, so it gives us hydrogen positive and it gives us chlorine here, which is negative. By now you should have known that the valence of chlorine is 1, and being a non-metal, that would be negative 1. So it's just a negative, we don't say 1 negative. Then the product side, this one is also to be split because it is aqueous. So sodium positive, aqueous. Then we have chlorine here. So chlorine negative, aqueous, but we will not touch water because you can see water as a state symbol Al. It is not aqueous. Okay, so we just write it as it is, H2O with the state symbol liquid. So the next step now is to split wherever, is to cancel out ions which are appearing exactly the same on both sides. So let's start with sodium ion. So we have sodium ion here. We check this other side, we see that we also have sodium ion. So these are exactly the same. So sodium ion we remove because they are the same. OH, we check for OH here, but we can't see OH here, so we leave it. H positive, we don't have H positive here. Cl negative, we see Cl negative here. So this one also removed. So what we have remained with is let me create space on top so that we can show clearly. Okay, so what we have remained with is the OH negative aqueous, and it is reacting with the H positive here. These are the only ions we have remained with, H positive, and the products, and we just have one product because this one and this one have been removed, so we just have H2O. Actually, this is a very important reaction. It is called neutralization when an acid reacts with a base. For now, you may not ask me what a base is because you will learn this. It is our second topic in grade 11. So this is neutralization. So this is what I wanted you to learn. I will post an exercise for you so that you can write ionic equations. Thank you.